Hey everyone, Grayson here with my old friend Otangelo, who watched my videos debunking James' tour on abiogenesis, as well as my amyloid world hypothesis video, and he has some thoughts, some criticisms. And before we begin and hear from Otangelo, just want to say that I'm. Hold on one second. I don't have mute. Okay, yeah. I just want to say that I am completely open and welcoming of criticisms for the amyloid world hypothesis. In fact, recently I have emailed several origin of life and amyloid researchers asking them to please provide me with some criticisms just so I can temper my own view and kind of see the positives and negatives. Uh, the crucial point here is scientifically meritorious criticisms. And that's the thing that I have yet to hear from the creationist side of things. So hopefully Otangelo can bring some of those tonight, but or today. But before we start, I just want to hear from Otangelo a little bit about what position or what claim are you advocating for? Is it that abiogenesis is physically impossible, or just that we don't have a working theory yet, or what I want to suss out what the exact claim that you're making is. So, Otangelo, go ahead and introduce yourself and clarify your position a little bit.
Yes, hello everyone. For who doesn't know me yet, I am evangelical Christian, and I study all topics related to origins for many years by now. And I have constant debates with atheists on various topics related to that in regards of also the origin of life. I have actually written a book which you can find and buy on Amazon. Just search for my name, Otangelo, and you will find it. It's on the origin of life and the virus world by means of an intelligent designer, the Watchmaker 2.0. So the main argument which I'm making in that book is that we see basically a very similar process to make a chemical factory, which is the cell, analogous to what humans do. So I am a machine designer, and let's suppose that someone, a boss, comes to me and tells me, make a machine or a factory with this specification for these functions. Then I will sit down, I will think about how to solve the problem, and I will use my intelligence, foresight, and then eventually, after the thought process, put on the table on my computer on AutoCAD drawing a project which then will specify precisely what that factory or machine has to be. So I will specify the size, the materials, how the individual parts have to be put together. And once this project is done, it is stored on my computer and then eventually through email or other processes transmitted to the factory. And there the factory workers, which understand the language of the drawing of the information, they will use that information and then based on that construct the 3D device of that project. And that is basically analogous to what we see happens in even the most basic cell and had to be there when life started. That is, you need to have a genome, you have to have a language, a code, the information stored in the genome. You need to have an information transmission system. You need to have a translation system, which happens through the ribosome. And then you need to have the mechanism to build the proteins, which are molecular machines. And then once they are synthesized in the ribosome, they have to be tagged and directed to the place where they will operate and do their job later on. So this is in its entirety a process based on information. And it has to be there all together, starting from the information storage device to the information transmission system, and then the proteins. There has to be a minimal proteome of proteins in a minimal cell. There has to be an interactome, that is a minimal number of proteins interconnected together in the right way. to get the metabolome, that is the metabolic processes which then are in operation in the cell. This is necessary. You cannot go lower than that to have life. You need also energy. Cells use ATP, and that is generated through energy turbine, which is ATP synthase. And you need the basic building blocks of life. You need lipids, you need amino acids, carbohydrates, and the nucleotides. So you need basically 4 basic building blocks, and they are complex. So if you don't have the basic building blocks, if you don't have the energy, and if you don't have the information, you cannot have life. You need to have all 3. So the amyloid hypothesis, which you are suggesting, Grayson, leads with basically a pre-RNA world where supposedly these amyloids had the function to generate some kind of information and then transitioned to nucleotide information processing. So this is which you are suggesting to that hypothesis, and I'm interested to learn more from you. I've just come across this in the last few days when I saw your video on this. So I'm pleased to be your guest and maybe be educated by you in regards of that hypothesis and see, scrutinize if it has some meat, let's say.
Cool. Well, thank you for that introduction. I think that was very comprehensive. I think that you listed out a lot of things that I would classify as assumptions. So I saying that we absolutely need this and that for life. At the moment, I would classify that as assumptions, as I have not heard justifications rationalizing them, but I'm open to hearing those rationalizations for assuming that we absolutely need a genome, we need this, we need that, because like you've said, I mean, I am a proponent of amyloid world hypothesis, which I think directly answers almost all of what you just raised. So is there a particular area where you would want to start out the discussion?
Well, I would be pleased if you can put in the side chat a link which I will give you. This is in regards of what might be a cell's minimal requirement of parts. Okay. There is another one which is the last universal common ancestor, what that would be.
Right, but we're not talking about the last universal common ancestor, are we?
Well, we can talk about the first universal common ancestor, but to be honest with you, I don't have yet encountered a science paper which was able to specify in more clear form what that progenot would be. So I think that it is very difficult, and science doesn't have an answer in regards of what that supposed first or last universal common ancestor would be constituted of. But there are science papers out there, and they list some minimal requirements. And I would say that I gave you a concise 3 points, which I think if you don't have one of the 3, you cannot have life. So I can even reduce it further and say life is chemistry and information.
Pause. I just want to clarify. The last universal common ancestor has almost nothing to do with abiogenesis or the origin of life, right? I mean, in everyone's model, universally accepted, the last universal common ancestor was not the origin of life. So if we're going to have a discussion about the origin of life, then the last universal common ancestor and its characteristics is not, that's a different conversation. Okay, so I'm interested in your 3 criteria that you say are necessary for life, but just recognize like that the last universal common ancestor is a different topic.
Well, I would say, as I said previously, I've not yet encountered a science paper which would define very precisely what the first universal common ancestor would be. And I would go further than that. Not even what a last universal common ancestor would be. There are several science papers which try to describe it, and you will see that each of the proposals is quite different than the other proposal. So nobody has actually a clue in regards of that, which of course makes it a little bit more difficult, because you will need a framework to know what are we investigating, what is life after all, what are we trying to explain. So the difficulties surely start at this point. But
okay, so again, let's move beyond the last universal common ancestor, because it's not abiogenesis. It is not the topic. If you want to ask what is life, let's just go with the consensus view of the 7 criteria that designate something as living.
Okay, we can do that.
Yeah, so, growth, metabolism, reproduction, all of those, organization, the 7. So we'll just go with that for the sake of an operational definition for the discussion. So you're saying that there are 3 criteria that are absolutely necessary from the very origin of life, right?
Yeah, so can you give me a handle so I can put these links in the side chat so people can access them after our conversation?
Would you want me to make you a moderator?
Yes, please.
Okay, can you comment so that I can see your... I'm not seeing your on the comment on the YouTube live chat.
Yeah, just give me a minute. I will do it here.
Okay.
Yeah. So you can do it now.
Okay. All right, you should be able to post links. Don't abuse your powers.
Yeah, I'll try. No, I won't do that. Okay, great. So, what is life? This is in the link: reproduction, metabolism, homeostasis, nutrition, complexity, organization, growth and development, information content, hardware, software entanglement, and permanence and change.
Okay, so yeah, what are those? Well, what are you saying that the very origin of life, what needs to be in place there?
Well, as I said, this is a very difficult question. Science doesn't have a consensus in regards of that. I have tried to investigate that in my book, and I've basically sticked to Pelagibacter rubique. This is a bacteria which is known today to be the smallest life form. It's a bacteria.
Hold on 1 second. Hold on. I'm going to read you directly from a scientific source here, okay? It says a minimal living system may be viewed as a self-sustaining chemical system capable of Darwinian evolution. All right? So that is the consensus view for what is minimally required for the origin of life. A self-replicating system that undergoes Darwinian evolution. That is the answer.
Yes, this is a good description. You need evolution. It needs to be able to evolve, to adapt to the environment. This is NASA, which has given this description. Another good, very succinct one is information and chemistry. Okay, so,
sure.
Yeah.
And I would argue, my position is that amyloids meet that minimum requirement.
Yeah, how do you come to that conclusion?
Well, I look at the requirement, I look at what amyloids are capable of, and I see that amyloids meet that requirement.
Okay. Do they do metabolism?
They're certainly capable of catalyzing reactions that help to facilitate their own self-replication. So I would say that is a primitive form of metabolism, because ultimately that is what metabolism is.
Okay, but I would say that you need the 4 basic building blocks of life, which are nucleotides, amino acids. Well, nucleotides because they are they make up the information storage system,
but amyloids can do that.
Transition system.
Amyloids can store information and pass it on in a hereditary sense. So you don't need nucleotides from the beginning. Amyloids can do that function.
Okay, so let's work with that. So you need amino acids, which make up proteins.
Yes.
I think you would have to elaborate how amyloids can form tertiary and full quaternary structures. I've not seen that in the papers that you provided me. I've seen that they make just up beta sheets, but you need also alpha helices, and you need to be able to get three-dimensional structures, and they have to be hydrophobic and hydrophilic. So do they do that?
Yeah, so fibers of amyloids are capable of forming hydrophobic and hydrophilic pockets. So that has been documented. And if I can find in the paper here, the paper actually does mention the tertiary and quaternary structures forming spontaneously during amyloid formation. So that has also been addressed in Greenwald 2016.
Okay.
I'll try to get the exact quote here, but I don't have the PDF of the paper pulled up right now. So let me try.
Not a problem.
But yeah,
I'll just go with what you're saying. I've not studied it, so I cannot say anything if that is true or not. I actually asked ChatGPT, and it said to me following. Let me quote that to you.
All right.
The question which I asked ChatGPT was this: by the amyloid origin of life hypothesis, is it clear how beta sheet amyloids could evolve into alpha helices structures and ultimately into tertiary and quaternary protein structures? And the answer it gave me: it is indeed unclear how beta sheet amyloids could have evolved into alpha helices structures and ultimately into tertiary and quaternary protein structures. The transition from beta sheet amyloids to alpha helices and more complex protein structures would require significant changes in the amino acid sequences and interactions within the protein. The formation of alpha helices and other secondary structures typically involves the specific arrangement of amino acids with particular chemical properties and the formation of hydrogen bonds. This transition would likely involve a complex series of evolutionary steps that are not yet fully elucidated. While the amyloid origin of life hypothesis provides a potential starting point for the emergence of protein-like structures, it does not provide a complete explanation for the evolution of the diverse protein structures observed in modern organisms. The evolution of complex protein structures involves a combination of genetic mutations, natural selection, and the influence of environmental factors over long periods of time. I go forward and ask other questions, but that would take too much time now to read all. But yeah. I will put the link here in the side chat so the audience can look it up and study this.
Just for future reference, I'm going to ask that we avoid just reading text just because it gets a little bit monotonous to listen to. I'd rather just have an actual discussion. That being said, of course, what am I about to do? I'm about to read a sentence. So yeah, hypocritical. But I just wanted to read this because I did find the area in the paper where it says the robust formation of amyloid-like precipitates from amino acids under conditions relevant to a prebiotic Earth reveals an unexpected ease of creating a higher order tertiary and quaternary structure in the context of short peptides. So there is the explanation there. In Greenwald et al. From 2016 about the formation of the quaternary and tertiary structure, and they were actually surprised by the ease at which amyloids were able to do so.
Okay, well, the thing is, first of all, as you know, you need the right sequences of amino acids to have strands which then eventually can form into 3D forms. And you have also proteins which have pockets with active centers, with cofactors. And there are many, many different proteins required. You also, to start life, that have these cofactors in their pocket, which then perform the reaction.
So let's go
So
one step at a time. Let's go one point at a time here. So amyloids do form spontaneously, like with all kinds of sequences. You do not need a specific sequence. There are a very large number of different sequences that will readily form amyloids. So it's not like you need to calculate what are the odds of getting this specific sequence. It's a much more difficult calculation with a much higher probability because there are so many different combinations that will spontaneously form amyloids. So pretty much every single protein sequence has the capacity to form amyloids. Some are more readily forming of amyloids than others, though. So yes, there will be some amino acids that have a higher chance, like some sequences that have a higher chance of forming amino acids, and the amino acids that have those highly reactive side chains are obviously not the very first ones that would be forming amyloids. However, it has been demonstrated that amyloids do have the capability to form peptide bonds with those highly reactive side chains, such as lysine. That's what Dr. Tour brought up in his review. So I would point to Greenwald et al. From 2018. In that paper, they show an amyloid catalyzing the peptide bond formation for lysine, which is one of those highly reactive side chains that you're bringing up. So amyloids can actually do this chemistry.
Yeah, I mean, the polymerization of amino acids is the same compared or analogous to you wanting to build a house and you having, or we can take Lego blocks, for example, and in order for you to build a Lego house, you need to have the Lego blocks, and you have to have them in the right way that they can stick together, and then you can build a wall. And you need to have these building blocks specified and complex. And I mean, in the case of Lego blocks, we know that intelligence makes them in the order with the right sizes in order to stick together just by the forces. In regards of amino acid polymerization, of course, it's much a more complex process because in cells, the ribosome is involved, which is extremely, maybe one of the most complex molecular machines known to exist. And that wasn't extant prebiotically. So the thing is, if you need specified complex building blocks to build a Lego house, you need also specified complex building blocks in life. We know that there are 20 used and they are specified, they're complex. And supposedly there were over 500 different amino acids extant prebiotically. But I would say that the number of molecules on the prebiotic earth can be said to be unlimited almost, because you can have all kinds of different structures. So how do you select from an unlimited number of molecules a very specific set of amino acids, which then in the future would be used to make proteins or amyloids or whatever, if there was no selector prebiotically?
So there is a selective process prebiotically, and that selective process is the formation of amyloids itself, which does select. Like we already went over, some amino acid compositions will more readily form amyloids than others. So that is your selection right there.
Okay, so you have a structure of amyloids prebiotically. Go from there.
Okay, so yes, those amyloids are going to be selectively extending themselves, self-replication, using the amino acids that, like, again, so it selects chirality. You don't get right-handed amino acids incorporating into a left-handed amyloid. So you get homochiral products. You get only the products of the amino acids that will readily add to the amyloid template. So this is the selective process, is the formation and the elongation of amyloids. This is what is selecting for the amino acids that is added on to the amyloid.
So can you a quick explain for the audience maybe what is an amino acid?
an amino acid. It's a categorization of chemical molecule, like based upon like uh, nitrogen and an amine moiety, and then like a carboxylic acid. I mean, you have an amino acid background that's nitrogen and carbon containing, and then you have a little side chain which comes off from this backbone, and the identity of that side chain is what causes you to identify what type of amino acid it is. Generally, there's a minimum of 20 amino acids in modern life today. However, there are organisms that use more beyond this 20.
Okay, you have also a hydrogen side chain. Okay.
Yes.
Okay. So
The hydrogen side chain is the most simple of all of the amino acids.
yeah. So the carbon atom, can it have more than 4 binding sites or less?
No, it can have less, but typically it's going to have a tetrahedral bonding structure with 4 bonds.
Right, but it can have less or more, right?
It can have less, but it's the most stable when it's formed 4 bonds. Yes.
Yes, but you find on a prebiotic earth all sorts of carbon atoms with 2 binding sites, with 3, with 4, with 5. There is
Yeah.
no limitation in regards of that, right?
Well, there is a limitation in regards to the number of bonding sites. I mean, you're not going to find carbon atoms bound to 9 different things, but
Yeah, but I mean, it is not constrained to just 4 binding sites.
sure, yeah, you have variations within that.
Okay, so you need actually to select, first of all, a carbon atom that has the 4 binding sites, and you need to have the homochiral form. So how do you select between the left and right-handed chiral form on the prebiotic?
Amyloids do that selection, like I already said. Amyloids do not form with a mix of chiralities. You don't get right and left-handed amino acids coming together to form amyloids. Amyloids themselves will form only homochirally. So, like if a left-handed amyloid is growing, it will ignore all of the right-handed amino acids. It will not add those to its structure. It will preferentially select only the same handedness as the amyloid. So there's your selection right there. And this is also true in the initial formation of the amyloid.
Okay, so you can have basically, let me suppose, just a right or left-handed amyloid chain, but how do you select the side chains? You can have alpha side chains, beta side chains, gamma side chains. You can have all sorts of side chains and also the different structures. What selected those which then would eventually in the future be part of life?
Yes. So the way that amyloid replication works is that the original amyloid forms a template. And as the amyloid grows, it grows based on that template. So the sequence of the original amyloid is reproduced. That's like that's why you have like a preferential selection for only the certain types of amino acids that were a part of that template. It's not perfect. It's not 100% accurate. There is variation in that, which is very important for natural selection and evolution, but it is like going off of the template.
Okay, so you have about 500. Let's work with 500 different prebiotic amino acids laying around on the prebiotic earth. They are mixed with all other kind of sorts of mixtures and molecules, carbons with other side chains, numbers, and what is the maximum size of your amyloids? I've not studied this.
I'm not sure in terms of the maximum size, in terms of nanometers, or in terms of amino acids in the chain, but I do know that once they reach a certain size, they can fragment into like 2 daughter amyloids. But generally, amyloids will form kind of fibrous networks. So you have like huge interlocked networks of amyloid fibers that split apart, that grow. So Each individual fiber, I don't know what the size limit of that is, but they kind of all come together to form these vast networks that I don't know if there's a limit on the potential size of those.
Okay, so what limits the inconcatenation of in the future life relevant building blocks? If you have over 500 and other molecules laying around, if they can concatenate to form these amyloids, you can use all kind of amino acids, right?
So my understanding is that at least the amyloid formation papers that I've seen only have used, I think, up to like 7 of the different amino acids. So I'm not sure if like if you have just all of these different amino acids present, like 500, like you're saying, um, I'm not sure which of those would be the ones that would be most readily forming amyloids. But obviously, there's going to be differences in the amount of those amino acids you have. So obviously, you're not going to have equal amounts of all 500. Some are going to be more common than others. Like, for example, the one that has just a hydrogen atom as its side chain, probably going to be way more common than the others. That explains why it's one of the most prebiotically relevant, because it's one of the easiest ones to form. If you have some super exotic, crazy amino acid that's not even in life today, the concentrations of that are going to be probably very low. So they're like the environmental composition of which building blocks are even available is going to play a huge role.
Yeah, I see a big problem here. And I'll give you an example. If you want to make a drug for a specific solution of a disease or something like that, you cannot take any kind of molecule. You need to have the right composition, which then will permit the right reaction in your body that will perform what you need in order to cure the disease. So you need to investigate which combination works. And I see the same situation in this case. If you have an unlimited number of building blocks on a prebiotic earth and you don't have a selection mechanism of those which are relevant in future complexification, then all you will always have is just a random chaotic coming together and asphaltization of molecules and nothing else.
Okay, so let's go with that. Okay, so the very initial formation of amyloids is going to be that kind of not truly random, because like we already said, some amino acids have more of a tendency to form amyloids than others, but an essentially randomized sequence in these very first amyloids, right? So yes, it's going to be incorporating all kinds of amino acids just from what's available. However, then natural selection kicks in. So you've got self-replicating amyloids where you have a variety in your population. Like all these different amyloids are going to have all unique compositions because they're forming, essentially random compositions. So you have variety. You have differential fitness effects, as in the different varieties of amyloids are not all going to be capable of the same catalytic abilities because of their differences in composition. So some of them are going to be more efficient at replicating themselves than others. So you have differential fitness effects, you have variety, you have self-replication. Therefore, you have natural selection and Darwinian evolution, which then will refine the compositions of these amyloids to make them more efficient at self-replicating. And so all of these weird exotic combinations of amino acids are not going to be selected for because they're not as efficient. You're muted, Otangelo.
Yeah, I have just put in the side chat a link to an article, to a collection of the question, the possible mechanisms to explain the origin of life. And you cannot invoke biological or Darwinian evolution in regards of the origin of life. And there is...
Really quickly, Otangelo, sorry. Somebody was asking, are amyloids catalytic molecules? Yes, they are. If you check out my videos on amyloids, I do provide the sources showing the catalytic diversity that amyloids are able to produce. So, yeah, there are sources showing the catalytic ability of amyloids. Sorry to interrupt.
No problem. Well, I think that molecules, they have no urge or necessity or will to become part in the future of a living system.
Why is that
So,
necessary?
well, because I mean, what would molecules laying around on a prebiotic Earth do? Would they? Why would some mechanism or so select those which then in a distant future would become part of a living system?
Okay,
Molecules, they have no necessity of that kind of
answer
sort.
that. Okay, so you're saying what would these molecules do? They self-replicate. This has been shown. Amyloids do self-replicate. So that's what they're doing, right? And as long as you have self-replication, variety, and differential fitness, then you have all of the ingredients for Darwinian evolution. So what you're selecting for is obviously like if you're thinking about if you have variety A and variety B, and they're both replicating themselves, but variety A replicates faster. What's going to happen over time is that variety A is going to take over the population because it's replicating faster. It is more efficient at using resources to replicate itself. Therefore, as if you just let time go on in that scenario, any simulation will show you that the faster reproducer will take over the population. Ergo, it is selected for natural selection.
Okay, let me quote you here from Philip Johnson in Darwin on Trial. He says, Darwin persuades us that the seemingly purposeful construction of living things can very often and perhaps always be attributed to the operation of natural selection. If you have things that are reproducing their kind, if there are sometimes random variations nevertheless in the offspring, if such variations can be inherited, if some such variations can sometimes confer an advantage on their owners, if there is competition between the reproducing entities, if there is an overproduction so that not all will be able to produce offspring themselves, then these entities will get better at reproducing their kind. What is needed for natural selection are things that conform to those ifs. Self-replicating cells are prerequisites for evolution. None of this was available prebiotically to explain the origin of the first life form. So there are other papers which I can cite which say the same. There was no prebiotic natural selection.
So that's okay. I want to say I agree with almost the entire thing up until the very end, where I agree with what's necessary for Darwinian evolution. But then he says that you need self-replicating cells. No. All you need is self-replicating chemical systems like amyloids. Amyloids check off all the criteria that you just listed through. So I'm sorry that author doesn't seem to be aware of amyloid chemistry, but amyloid chemistry very clearly answers what they just raised. If there's also a paper I have right here, I don't know when that quote was from, but this is from 2021. Self-reproduction and Darwinian evolution in autocatalytic chemical reaction systems. So it is known about. It is a consensus view that chemical systems can undergo natural selection and Darwinian evolution. As long as they are, like I said, self-replicating, have variety and heredity and differential fitness, then you get natural selection. That's the mathematical formula. So if A, then B. If we have these things, which we do for amyloids, then they're capable of natural selection and Darwinian evolution.
Yeah, you need to have a population. You need to have one variety, yes, which then would overcome the others in regards of fitness.
Yes.
And you have no fitness if you don't have life, and molecules, they are not life.
That is a fundamentally unjustified assumption that you just made, because I just showed and I explained how amyloids do have fitness prebiotically. I don't know if you missed my explanation, but obviously, if they are self-replicating, the fitness is whichever variety of amyloid replicates itself the fastest. That is the selective pressure.
Okay, so let's suppose that what you're saying is happened prebiotically. Okay, so you have a population of self-replicating amyloids, which by Darwinian evolution, they perpetuate.
Yep.
Go from there.
Okay, so from there, you're going to be refining the composition, the sequence composition of the amyloids to streamline them for the fastest reproduction possible, right? So from there, it seems pretty obvious, like that you're on your way to life, right? I mean, if you have a chemical system undergoing Darwinian evolution, I think we agreed at the beginning that was the necessary criteria for the origin of life.
Yeah, if you just remove all the other parts which are required, you need to have energy, you need to have a system of 4 building blocks, you need to have amino acids. How do you go from these amyloids to the 4 building blocks of life? How do you go to the nucleotides?
Okay, so this is a great question. This is an ongoing area of research, but that does not mean that we are completely clueless about the answer. But I did want to just disclaimer at the beginning that this is open and ongoing. So far, we have experiments that have been done on amyloid formation and like what amyloids are capable of doing. However, to my knowledge, no experiment has yet been done on an amyloid RNA world. So how, like, to characterize the exact interaction between amyloids and RNA. But we do know that amyloids do interact with nucleotides. They do interact with triphosphate nucleotides like ATP. They also interact with lipids. Amyloids have a very strong interaction with lipid membranes. So because the amyloids have this like 2-dimensional repeated pattern, they like love to stick onto lipid membranes. So we know, although we don't have the exact characterization for what the exact relationship was between amyloids, RNA, and lipids in this very early stage, we do know at least that amyloids do have strong capabilities to interact with all of these molecules. So they interact with ATP. They're capable of utilizing the energy stored in ATP to do work. So amyloids have that capacity. They are able to hydrolyze that phosphate bond and utilize the work from ATP. They're able to bind with nucleotides. They have interactions with RNA. So we know that amyloids and RNA do interact with each other. The experiments have not been done yet to characterize the nature of that interaction in a prebiotic sense. Nobody has done this research in regards to origin of life. So I agree that would be really awesome research to see and to characterize the nature of this interaction. We don't necessarily have all that data yet, so it's not a perfect 100% like complete theory, but I think that there is very strong evidence that at least that interaction does happen. Like they interact in some ways. And what's really interesting is, so once you have these nucleotides that, again, are naturally occurring. I mean, we have found nucleotides in meteorites just like we found amino acids. So these building blocks are naturally occurring.
No. Let me interrupt you here.
Okay.
We've not found nucleotides in space. We have found nucleobases, which are together with all sorts of other molecules. We have not found nucleotides in space. Okay.
What did you just say, that we find nucleotides together with all other molecules?
No, not nucleotides, nucleobases. What is the Do you know what the difference is between nucleotides and nucleobases and nucleosides?
Yeah, like the phosphate backbone, and you're going to be missing parts like with like the sugar and phosphate for the
Right. Yeah.
nucleobases.
So there have been found some nucleobases in space in meteorites, but not nucleotides. Okay, but
Okay, if
you
that's
know,
true, I apologize for misspeaking. I'll just refine that. So yes, nucleobases in space. Yes. So, but
yeah,
there
but
is the interaction with like adenosine, for example, interacts with amyloids. That has been shown experimentally. Um, like amyloids are capable of cleaving that phosphate, that triple phosphate bond in ATP, and then binding with adenosine. So that at least, like, we have shown that there's an interaction there. But I don't have all of the answers for you at the moment. What I will say that um, one of the key researchers behind like amyloid world, he did just last year in 2022 give a presentation called peptide amyloids, fatty acid vesicles, and RNA together in the origin of molecular complexity. I've been trying to find this presentation online so that I can look at what he's talking about. And I emailed him just yesterday asking if he's got it available anywhere. So um, maybe that would give us a better idea of how all of these building blocks fit together for these early protocells. But I haven't been able to track it down yet.
okay. First of all, the term protocell is for me something pseudoscientific because nobody has ever shown me what actually a protocell would be. Okay. Now, in regards of what you presented me so far, I think that um, there would have to be many, many thousands and thousands of other questions to be asked and answered by science in order to come to a first self-replicating living cell similar to the ones that we know of, which are free living, like Pelagibacter rubic. And Lynn Margulis, she said very clearly to go from a random bunch of molecules on a prebiotic earth to a first self-replicating cell would be a bigger trajectory and a huger step than to go from a first living cell to Homo sapiens.
I
And
agree.
yes, and who study these sort of things, you know that this is true. So the truth is, and many which do not study the origin of life do not know that a cell is, in a literal sense, a hyperly complex chemical factory. And to explain the origin of that factory is something which science is completely clueless how that could have happened.
I
So maybe
disagree.
there, well, okay, we can discuss that, and I will justify what I am saying. But um, I mean that your amyloid hypothesis is one amongst dozens which I list in my library, and it might answer some or a few questions. I'm not taking that away from you or from the scientists which study these scenarios, but if I give you everything which you presented me right now, that you have self-replicating amyloids that they can polymerize, stick together, to go from that to the four basic building blocks of life, to these building blocks form self-replicating cells with all the metabolic pathways, with the signaling networks, with the information system, with the genetic code, with the translation system, with the transcription system, with all that sort of things, with homeostasis, with the capability to adapt to the environment. These are all big, big questions which I have not found any compelling explanation whatsoever in the scientific literature. And as long as this is not presented, I remain skeptic that a naturalistic, non-guided explanation of origin of life is not only plausible, but even possible.
Okay, so I was disagreeing with your characterization that we are clueless. I think that was the same thing that James Tour said. I think that obviously, like what we've already gone through, I would classify as clues. So I just would disagree that we're clueless. I think that a lot of what you said um, was more or less true. I think that I disagree with the notion from the quote that you read about the first self-replicating cells, because I think that there was self-replicating chemical systems before there were cells. So you're really just talking about the first cells, not the first self-replicating cells. You follow my critique there. So um, I I think that you have to basically start with autocatalysis of some way. You need to start with a self-replicating chemical system that is capable of undergoing Darwinian evolution. I think that the fact that we have shown chemical systems that are capable of undergoing Darwinian evolution shows us that we are not clueless for the origin of life. But your critique that in terms of how we get from these self-replicating evolving amyloids that undergo natural selection, how do you get from there to the development of the genetic code is definitely a huge open question. So I will freely admit that. However, on the topic of whether or not we're clueless about how that happened, I would just disagree with that characterization because, like we said, I mean, we know how ribosomes work. We know where we have to end up eventually. And if we're starting with amyloids interacting with RNA, then we have the starting framework for an amyloid RNA world, an interacting world between those two. And you have to get from there to something that can functionally resemble a ribosome. Okay, so you have an interaction between RNA and amyloids. Now, the
Well,
question in my mind.
let me just quote you here. I just put in the side chat a link to the question of the genetic code and its origin. And I'll quote you here, Eugene Koonin from 2012. And he admits, in our opinion, despite extensive and in many cases elaborate attempts to model code optimization, ingenious theorizing along the lines of the coevolution theory, and considerable experimentation, very little definitive progress has been made. Summarizing the state of the art in the study of the code evolution, we cannot escape considerable skepticism. It seems that the two-pronged fundamental question, why is the genetic code the way it is, and how did it come to be, that was asked over 50 years ago at the dawn of molecular biology, might remain pertinent even in another 50 years. Our consolation is that we cannot think of a more fundamental problem in biology. This is just one of many other very difficult problems which scientists which work in the field, they openly admit we do not have a scientific explanation. They can say we are working on it, but I would say if you look after 70 years of intensive scientific investigation into all these fields, and they have to admit after so much research and intelligence gone into trying to find solutions, and they cannot present anything, that should put the question mark into the whole field. And of course, then the end question is, well, what about if we would put intelligence into the mix as a causal explanation?
Hold the thought right there. I just wanted to say I'm disagreeing with your characterization that we are somehow clueless about the evolution of the genetic code. You're welcome to read the many papers on this. There's one from 2021 called The Evolution of the Genetic Code, where they literally say that the result is a highly detailed scheme that describes the placement of all amino acids in the standard genetic code. Their model has explanatory powers to explain how this originated. So we do, and that's just one. Here's another one right here from a different author from 2020, Evolution of the Genetic Code, Evidence from Serine Codon Disparity. So we are not clueless on the origin of the genetic code either. There have been several proposed mechanisms and models. It's not like we're just scratching our heads and we know nothing. There's tons of literature on this. And if you notice from the dates that I just read, it's all still very recent. So I don't know when the quotes that you're reading are from, but literally, I mean, a lot of these papers are from the 2020s. And people are coming up with models for how the genetic code can form. So it's not. I would not say that we are clueless about this.
Okay, so let me ask you a simple question. Is meaning assignment something which we know is performed by intelligence? Yes or no?
I don't know.
Of course it is.
Well, if you already knew the question, I mean, or if you already knew the answer, then why ask me? I legitimately do not know. I mean, I understand the question that you're asking. Okay.
Okay,
Uh,
what is the question that I just asked?
you're asking about if arbitrary meaning assignment, that meaning value assignments, is something that is exclusively done by intelligence.
No, I didn't ask if it is exclusively made by intelligence. I asked if intelligence is known to be capable of doing meaning assignment.
Oh, okay, then yes. I thought you were asking, is it the only thing that can do meaning assignment?
Yeah. So you agree, obviously, we as intelligent beings, we know how to assign the word chair to the object with four legs which you
Obviously,
sit
yes.
on.
I agree.
Good.
I thought you were saying, is it exclusively the domain of intelligence that can do that?
Okay. So we know already that intelligence is capable of doing that,
Sure.
right? Okay. So there is no need by science to create a hypothesis and then test if intelligence is capable of doing meaning assignment, because we know already, we as intelligent beings, we do it all the time. Language is based on that, right?
I mean, I don't know if there's no need. There are plenty of scientific experiments that were testing things that were common sense. But okay, that's less of a meaningful quibble with what you're saying. I'll let you go on.
Yeah, but it is common sense. We know that intelligence can do it, so there
Yep,
is no
I'm agreeing
question.
that intelligence can do arbitrary meaning assignment.
Good. So when you see a translation book on the table and you have no clue how it came to be, you will immediately, by your background experience, know that someone which knows, for example, English, the Chinese, did write that translation book with the assignment of a word chair in English to the word shizi in Chinese, right?
I would say that my rationale in concluding that is from my previous experience knowing that humans make books.
Right, exactly. So we have previous
It's not.
experience. We know that intelligence is capable of doing this because it is something we have experienced, right?
um Yeah, but I would say that my rationale is not so more so like I'm not looking at him like, oh, well, there's arbitrary meaning of assignment in this book. Therefore, that's how I know that humans wrote it. I'm saying that my rationale is, hey, there's a book. All books that I've ever read have been by humans, and it is that experience that is informing my conclusion.
Yeah, yeah, we agree on that. So we know based on our background experience that intelligence is capable of doing meaning assignment, right? I think we can
Yeah,
both agree on that. Okay,
yeah.
so there is no question in regard of that. And what is the function of a codon?
The function of a codon, right? It's like the transcription translation mechanism. It's it's a central dogma of biochemistry, how you get from genetic information to proteins.
Well, it has nothing to do with transcription. It has to do with translation.
Yeah, okay.
Okay, so what would you agree that a codon is a word?
No.
Yeah, but it is a word. It is a genetic word because it
Well,
has meaning. Do you know what the meaning is of a codon word?
do you know what the meaning of a word is? It's a
No,
part
of
of
a
a spoken
codon. Oh, I can just ask, what is the meaning of a codon?
it corresponds to a particular amino acid.
Right. So it is assigned to a particular amino acid, right?
If you want to use that language, sure.
Well, what language would you use?
Well, I mean, this assignment that you're talking about just is contained within the structure of tRNA. So the fact that tRNA is built with little anti-codon end and then an amino acid end, that the tRNA is what is linking these two together. It's not like there's any decision making or assignment going on by any intelligence. It's just has
No,
to
of
do with
course not, because this is a pre-programmed process. So there is no intelligence constantly squibbling there or thinking, okay, there is a codon of an mRNA entering the ribosome. Oh, what amino acid do I have to put there? Of course not, because this is an automated process.
So that's why I would say that it's not a word, because when I say words, that is what spoken languages are composed of. So I'm not going to say that a codon is a word because it's not part of a spoken language.
Well, in reality, there is a science paper which has tried to make a parallel between spoken human languages and the genetic language, and amongst 13 characterizations, they have.
Sorry, I sorry to cut you off, but I'm not saying that they're not analogous. I do think that there is an analogy that you can make, but that does not make them the same thing. Just because I can analogize two things does not make them equivalent.
No, I didn't say it's equivalent. What I am saying that there are 13 characterizations of the human language, and 10 of them, they are analogous or equivalent to what science has discovered in the genetic language. So I think that you have already admitted that the codon, the three nucleotides, they are assigned, or there are 64 three nucleotide codons which are assigned to 20 amino acids.
Okay? I would say the wording I would say, because I would not use the word assigned myself. I mean, if you want to use that, fine, I know what you mean, but I would say that the codons correspond to the amino acids.
Okay, so we can use the word correspond to the set of 20 amino acids. Okay, so if you don't have the translation machinery, the ribosome, and all the parts which are involved in doing the translation, could there exist a genetic code?
So if you don't have the translation, could there exist a genetic code? Yes, but that genetic code would not be coding for amino acids. The genetic code would be storing information that would be relevant in without translation. So as in, it would be relevant for ribozymes, and it would be relevant for other nucleotides, but it would not be relevant for amino acids. But again, it's a little bit unclear of the order of which, like, this genetic code would have evolved. Would it have started with the proteins, or would it have started with the nucleotides? And there are competing hypotheses for which order.
Well,
so I'm not making an assumption in
that. How would it be related to ribozymes?
Well, so if you're saying the genetic code, if you're defining the genetic code as only the codons corresponding to amino acids, then no. But if you're defining the genetic code as just coded information within RNA,
that's not the genetic code. You need to make a clear distinction between the sequence of nucleotides or codons, which bear instructional assembly information to make proteins, and the genetic code, which is just the assignment of the 64 codons to the 20 amino acids. These are two different things. But if you don't have the translation machinery, then the genetic code would have no function, right? So I said that.
Sorry, I will. I did misspeak. I will grant that to you. Sorry. Whenever I was thinking of genetic information content, but you asked specifically about the genetic code, as in the translation of the codon. So I will grant that.
You know, Grayson, many do conflate the two because they have not studied the topic. And you see it many times still today, people saying, oh, but DNA isn't a code. You certainly have heard that before, right?
Yeah, I have heard people saying that before.
Yeah. So
I
this
will.
is
I
a
will. I mean, hey, I'm owning up to it. Is my bad. It's not that I haven't studied this. I mean,
no,
I
no.
do
I'm
have.
not saying that you have not studied this, but since this is a live stream and it will be recorded and people then will see what we are saying, and I know that there are many people still which have misconceptions. I will take the opportunity to clarify that, so
Okay, go
anyone
ahead.
can. Yeah. So when someone says, "Oh, well, DNA is not the code," and there have been many live streams in regards of that, then I agree. DNA is a polymer which stores genetic information. But the genetic code is completely different, and it is a real code in the sense that it really codes for proteins. It is a real assignment of codons to amino acids, so that there is no analogy or something like that. This is a real fact, a real assignment. And the big question which science is struggling with, which Kunin confessed, and I quoted him, is how this came to be. And you say, oh, but there are many different science papers here from 2021 and this and that, and evolution of the genetic code and this and that. But hey, think about it. If you have a genetic code which is not something physical, and you don't have the physical machinery actually to make use of that code, then why should that even come to be? Why should there be an RNA or DNA sequence with codon words when you don't have the apparatus or the machinery to actually make use of that codified information? This is a huge problem, and many
Yeah.
are
So
not aware of it and don't recognize it. And you will not find science papers which will recognize it because they are based on methodological and philosophical naturalism, where intelligence never comes to play as an explanation.
okay, so I want to say that I don't think that you've read all those papers. So I think it's a little bit presumptuous to say to characterize the content of the of papers that you have not read yet. I don't think that you have read the 2021 paper that I cited earlier, but if you read that paper, you still feel the same way. Fair enough. I think that there's a little bit of a putting the cart before the horse here, where you're saying that you absolutely need that genetic code to be in place uh, at the same time that you get the first interactions between proteins and RNA. But I don't think that that is necessary. I think that you can have uh, meaningful, impactful interactions between RNA and amyloids before any development of any genetic code, and that the role that these nucleotides are fulfilling is not the role that they fulfill today. It is not that they are coding for information for the production of proteins. It is that they are interacting with these proteins, working together with these proteins to perform catalytic functions together. So, like, you have lots of interesting structural and charge formations of these nucleobases that can have important catalytic roles when they're incorporated into amyloid structures. So I would say that the nature of that interaction between RNA and amyloid would not have been the current dogma that we have, where the genetic information is stored in the DNA and RNA and is then translated by the ribozyme into producing protein enzymes. That is not the nature of the origin of that interaction necessarily. So you can have interactions with RNA and amyloids in other functions outside of that central dogma. And
Yeah,
I think that you're potentially just ignoring all of that and how those could give rise to the current central dogma that we have today.
yeah. You state like RNAs and DNAs are a given, and I don't take that as a free lunch which you just can start with. And it is the same problem which I stated before. First of all, there are no naturally occurring nucleotides. No. Okay. So the question how nucleotides, RNA or DNA, merged prebiotically is an unsolved problem. It is a huge problem. I have videos which I can actually even link in the side chat so people can look it up. There are many open questions, and it is not a free lunch. You need to explain how did these RNAs and DNAs emerge prebiotically, and
Okay.
also the transition from your supposed amyloids to RNA. And RNA are complex molecules. They are made of three parts: of the base, of the ribose, and the phosphate, and they are linked in the right place together on the ribose. Nucleobases, we have just 4 nucleobases, or 5, and there is basically also an unlimited number of possible isomeric configurations. There is no restriction in regards of that. You need to select the right nucleobases. You can have different atoms in the structure, and there was no natural selection to have just the 4 or 5 nucleobases to start constructing RNAs. I would say, Grayson, that if you think carefully just about this problem, then you will, in the end of your thought process, come to the conclusion that natural selection is a dead end for the origin of life, because there was no natural selection of these building blocks, and you need to select them.
So, okay, let's just take a pause for a second. I'm not sure if I buy your claims that like RNA has never been found or has never been naturally formed, but
like if you quote from Shapiro, he said it very clearly.
Tabling that for the moment, what are the building blocks that DNA and RNA are built from today in your body? They would be
you need a complex metabolic network, and you need at least 400 enzymes.
So it's nucleoside triphosphates, right? When you have the synthesis of DNA and RNA, they are taking the nucleoside triphosphates and they are linking them together, okay? So the question then is, are nucleoside phosphates naturally occurring? And I think that the answer is yes. We find them in hydrothermal vents.
No, they are not naturally occurring. What you have are some nucleobases, but nucleotides have never been shown to exist. And ribose
I said nucleosides.
Yes, but nucleosides are ribose and the base put together. How do you link it together at the 2' end? You have five. You have 5 prime positions where you can put them together. This is a big origin of life problem. How you stick the parts together at the right place.
So the answer is amyloids, because remember, amyloids form a template. So they have catalytic activity that reproduces the same, like the conformationally same products each time, because they have enzymatic ability like that because of their structure. So it's the structure of amyloids that can act as a template. So once you have the interaction between nucleoside phosphates and amyloids, which has been documented, then you get whenever more nucleosides come on and you start forming these chains, you no longer have the ability to form them at any conformation, because they are bound with the amyloid and they have structural constraints to only form preferentially from certain conformations because of the structure of amyloids.
Okay, Grayson, let me repeat that again. I don't know if you have paid attention to what I said. You can have basically an unlimited number of different isomeric structures which constitute nucleobases. You can have nucleobases with different atoms. You can have nucleobases with 1 ring structure, with 2 ring structure, and there is basically no limit. And life uses just 5 different nucleobases. There was no natural selection prebiotically, and even your amyloids. And your amyloids, how do you go from an amyloid to a nucleotide or a nucleoside? These are different structures.
Yeah, you're not going from one to another. It's not like the amyloids are evolving into nucleotides. Obviously, that is a mischaracterization of the science. There is an interaction.
Clarify how you imagine that, because
okay, so you've already said, hold on now, because you said a lot. You said nucleobases are naturally occurring. you agree that they interact with amyloids because it's been shown. So there you go. It's not like one is changing to the other. You have an interaction there, and the structural properties of the amyloid conformationally constrain the reactions that you can do with that nucleobase once they're interacting with the amyloid. The structure of the amyloid explains the conformational constraints. And I just want to say also your it's sorry, I lost my train of thought. I'll let you respond there.
Well, again, I will insist on that. If you have basically an unlimited number of different nucleobases prebiotically, and there was no natural selection, and you can say, well, but replication of amyloids brings you to the specific 4 or 5 nucleobases used in life. Well, no, there is no reason why that should happen. They will just they will keep interacting in a chaotic, random, and stochastic manner, but a selection of these 4 or 5 bases, there is no reason why molecules should do that.
Oh, okay. Now I remember what I wanted to say. Yes, I was wanting to rebut your claim that there is, like, and this is all it is you claimed this, that there is no natural selection prebiotically. And I want to just show, like, I mean, that I've shown papers describing it, and like, this is an unjustified claim on your behalf. I don't know why you keep insisting that there can be no prebiotic natural selection or Darwinian evolution when it has been demonstrated.
Well, I am talking now specifically in regards of the nucleobases. As you know, life uses specifically 5 nucleobases and no others. And they have to be of a very specific complex configuration. They are made in the cell by very, very complex metabolic pathways, which the transition is not explained. How do you go from a prebiotic existent nucleobase to the ones which are catalytically and through the metabolic pathways produced? There is that's a huge gap which is rarely being discussed because science has no clue how that could have happened. A minimal metabolic path network consists of about 400 enzymes and proteins, and they are joined in the right fashion. They are like a production line, factory production line processes. So these enzymes, they need to be joined and lined up in the right manner. How that could have emerged without intelligence, nobody knows. Now, I will say something else, Grayson. Rather than say, oh, but there are new papers now from 2021 which try to explain how the genetic code could have evolved. I think you should, rather than just thinking, well, because there are some papers out there that claim that, therefore it must be possible or true, I would say start to think for yourself, because the concept itself is just nonsensical. It is only known of intelligence being capable to assign meaning to words and to create codes. Molecules and non-intelligent mechanisms, they do not have this capability. And this is alone is checkmate for any non-intelligent origin of life.
Okay, I want to get back to what you just said was a checkmate, but sorry, I was just fact-checking you, and you were incorrect in saying that nucleosides have not been found naturally occurring. They have.
No, I said nucleotides. I said nucleotides.
Okay, well, nucleosides, which are the nucleobase together with the sugar, have been found naturally occurring in meteorites. So it's not just nucleobases. There's also nucleosides, which are one more step closer to nucleotides.
Well, I don't know about nucleosides. I've not read yet a paper which says that there is ribose on meteorites. But even if there are a lot of other molecules as well there, and ribose is also chiral, you know that probably. And ribose disintegrates in a very short period of time, in about 40 days or so, in specific room temperatures. This is another big problem.
Unless, guess what? Unless it's bound to amyloid. then it doesn't. That's what explains why it would be preferential for RNA, for ribose and nucleosides to bind to amyloid, because then they don't degrade as readily and they can accumulate into long chains that, guess what? That's what RNA is.
Well, the problem is you have a lot of other kind of molecules which are irrelevant to the origin of life, and they are in a chaotic and stochastic matter mixed together, and there is no known mechanism
Natural
which
selection.
would have, well,
that's the known mechanism that does it, is natural selection.
This is your magical thinking, where you think that natural selection tops an intelligent cause for selecting these building blocks. But I say it again, natural selection has no goals to select something for a specific purpose, but you need to have in order to get something for a specific purpose, you need a mind, you need intelligence which has purpose and foresight and can select a building block in order to achieve a specific function. And if you have an unlimited number of molecules and bases on a prebiotic curve, I even give you that eventually nucleosides can bind to your amyloids. But besides those which are relevant to the origin of life, there will be also an unlimited number of other kind of molecules which are not relevant, with bases which are not used in life. And you have no mechanism to select one from the other.
Natural selection is the mechanism that you were describing. It is not necessary, and it is an unfounded and unjustified assumption on your part to claim it is necessary to have goals or foresight in this process.
Well, if you think so, I mean, I respect your opinion. I simply disagree.
All right. Well, again, your opinion is so far unjustified. All you say is that you disagree, but I would like a logical or rational explanation to justify that disagreement.
I gave you the justification. And I gave it right in my introduction. I told you
that intelligence is the only thing that can do it.
Yes, a meaning assignment. We know that intelligence is capable of doing it. I don't understand for what reasons people like you insist so much in thinking that intelligence is not the best explanation, while we know already that intelligence can make blueprints, can create codes, can create information storage mechanisms, can create information transmission systems, can create translation systems, can create meaning assignment, can create factories, can create machines, can create turbines that make energy. No, let me finish. We know that intelligence can do all this. We have never seen non-intelligent mechanisms creating complex chemical factories.
Hold on. You're saying that this is what we see intelligence do. Okay, fine. So let me justify what my position is. And that is, we have never seen intelligence exist without a nervous system. It requires some kind of brain. Every kind of intelligence that we know of. Okay? So there's the justification why you cannot have intelligence prebiotically. You don't got brains.
Well, I mean, this would be a completely different discussion, Grayson. We would go into dualism, monism, origin of everything. You know, it would be a larger discussion in regards of what kind of mechanism or cause explains best our existence. And I have repeatedly asked atheists in regards of that, and I've never got any meaningful answer besides, we don't know yet, we are working on it, and this kind of answers.
So I was just saying that you had asked me to justify why I don't think it's intelligence. You said that is my justification for why I don't think it is intelligence that did this, because this is prebiotic. And to my knowledge, there is no example of prebiotic intelligence that is known to science. So every example of intelligence requires a brain, a nervous system that we know of. It's not like there's any example of intelligence that you can point to that exists without a brain or intelligent, or like you might say computers, but again, we don't have generalized intelligent AI yet. So,
Well, if you're fine, we can go into a different topic than what we propose to talk about. I'm okay with that.
I mean, hey, maybe we could do a follow up. We've been going on for about an hour and a half. I think that we've touched on a lot of the topics of abiogenesis and amyloids. Um, is there anything that you feel like we didn't get to in regards to specifically like abiogenesis?
Well, I mean, we can sit here and talk until the end of our lives in regards of the topic, and we'll have still topics to talk about. So,
Yeah.
but yeah, I think 1 hour and a half. It's good to maybe end the stream, and then we can have follow-ups and eventually even
Okay.
talk about other topics.
Cool. Well, sounds good. Thanks for coming on, Angelo. Sorry, Otangelo. I know that it was an unmoderated discussion, so I hope that you feel like at least you got to state your piece. It wasn't openly hostile. I don't think it was. So I'm glad that you came on the stream. I've been trying to get you to come on the stream for a while now, but I think that you maybe weren't aware of me or my channel. So thanks for coming on. I appreciate the discussion as always. I've been wanting to do more an abiogenesis debate for like literally since I made the channel. I've been wanting to do a debate on abiogenesis. So this whetted my appetite a little bit. Guys, let me know if you enjoyed this video, this topic for this debate. I would love to do more on abiogenesis. Obviously, the video that I just did, debunking James' tour, has gotten an awesome reception. I've been really happy with it. That's actually the video that got this conversation with Otangelo arranged. So very happy with how the channel is growing. I plan on doing more debunk videos in the future. So let me know if there's anyone specifically who you'd be interested in seeing me debunk. But other than that, Otangelo, thank you for your time. Thanks for the conversation. Like the stream, subscribe, and thanks. Have a great day, everyone.